Remember when robots only existed in your favorite sci-fi movies? Well, brace yourself because a few years from now, chances are that you're probably going to bump into one while taking a night walk. But it shouldn't really surprise you because robotics engineering is easily one of the fastest growing fields in engineering today, and robots are the future. In today's video, we'll take a deep look into what exactly robotics engineering is all about. Right from what robots are capable of doing to what a day in the life of a robotics engineer looks like. Consider this your favorite YouTube robotics class. Let's do this. What really is robotics engineering? So, robotics engineering is a field of engineering that involves the construction, design, application, and operation of robots, or simply put, a field of engineering that involves building machines known as robots that replicate specific human actions. These human actions have evolved over the years into more complex tasks, such as performing surgeries in hospitals to leading exercise sessions. In fact, the statistics say that in 2005, about 90% of all robots were found in factories, basically just assembling cars. However, thanks to robotics engineering, there are a host of robots today that perform exciting tasks, such as supermodel robots. Wait, a supermodel robot? Bet you haven't heard of any. Well, I implore you to check out Shootugram on Instagram. You'll definitely know what I'm talking about. Anyway, have you wondered what goes into making all these interesting robots? Stay tuned. We have the answers coming right up next. What exactly do robotics engineers do? A day in the life of a robotics engineer is fun, but you already know that. However, the average robotics engineer has to be knowledgeable in a pretty long list of other sciences. I'm talking mechanics, electronics, computer science, cognitive psychology. So you'll be right to call them nerds, especially because of the time and dedication needed to design and ensure the workability of these robots. Even before the entire process begins, the first step is usually to decide what precisely the robot will be used for, which typically involves an in-depth analysis of the problem the robot will be built to solve. Questions such as these are analyzed. Is the robot's task going to be repetitive? Is that task dangerous for humans? What are some of the robot's restrictions in implementing the task? The answers to these questions give the robotics engineer a clear idea of how to design and build the robots, which we'll talk about next. But not until you do this one thing. Kindly subscribe to our channel if you want to keep in touch with all the latest in tech. This channel's got you covered. So hit that subscribe button now. Design process. Now the design process is pretty much computer-aided. A host of 3D computer-aided design, CAD tools are used to not only create, but modify and optimize the design. The software helps to improve the general quality of the design and the overall productivity of the designer, as well, who in this case is, of course, the robotics engineer. But the best thing about the CAD software is that it protects the inventions of the robotics engineer by proper documentation and database management. Nobody can steal your ideas if you used a CAD. That will absolutely suck if it actually happened, don't you think? Well, after the CAD software does its job, another software known as a computer-aided manufacture, CAM, comes in to help the building process. And we're getting into that next, building the robot. So the building process is typically the longest and most tedious in the whole robot making process, mainly due to the level of technical acuity that a robotic engineer must display, which is why you only have most engineers focusing on a few pet projects throughout their careers. Still, there's no doubt that the problems these robots end up solving make all that time spent building them worth it. Take a surgery-performing robot, for example. The robotic engineer has ended up not only reducing the workload of surgeons, he or she has also added more precision and accuracy to the entire surgery process, thereby saving a lot of lives the process. That's an invention worth a lifetime, if you ask me. By the way, are you enjoying what the job description of a robotics engineer looks like? Or do you have dreams of becoming one but don't know where to begin? We have a solution. Watch our video titled, What to Study to Become a Roboticist, 5 Best Robotics Engineering Courses. After watching this video, you should get all the help you need. I can promise you that. Well, A robotics engineer certainly needs help building a robot. That's despite all the knowledge they carry in their brains. It's just the nature of how complex the robotic engineering job is. A computer-aided manufacturing, CAM, software is meant to offer that help. The software works by primarily controlling machine tools in manufacturing workpieces that are needed to speed up the robot production process. But here's what note: a CAM software is literally just an enabler. So the actual robot building work comes down to how the robotic engineer employs the software for the needed specifications, and they usually ace it. As I have repeatedly said, robotics engineering is fun. Still, even more importantly, it offers robotics engineers the chance to solve real-life problems by helping to make work easier and eliminating all the risks involved. So it really is a pretty cool field of study to pursue. What do you think? Hop in the comments and let us know. That's it from us today. I hope you enjoyed this video. We'll see you next time. Thanks for watching.